Hello everyone. So today I wanted to do a bit of a question. So I wanted to study something out because I find this type of questions very interesting. So I wanted to give them a go. Now this is an area that I'm gonna calculate or attempt to calculate. And I wanted first, when I wrote the title, to just do like a little iteration of, and now I'm really not sure how to pronounce this, but I think it's the Koch Snowflake. If I pronounce this one wrong, please excuse me, but I'm gonna do the area of a snowflake like that. But then I realized, you know what, if I'm gonna do one iteration of this, I would like to see if I can get a general formula for the general area of a snowflake like that. So what I mean by this is I've started with a triangle, then I splitted each side of the triangle in 3, and I've made another triangle, and I've done the same on the other sides. And as you can see, I have a couple of extra triangles. So each side then I split into 3, and I've made it some other little triangles. So I'm gonna insert a little clip of how I've done this. It's not a perfect drawing. It's not really the most beautiful drawing ever, but I hope it will help you understand. So I want to do an area. Now, as I do more iterations over here, I get to like even more little triangles, and I'm actually pretty curious to see if I can find out, maybe not like the full area of this, because this is like a fractal. It will just go on and on and on, and if you zoom in on a little bit, it will just have even more triangles, which is something I can't really draw. So I would have to make another triangle there, there, and it's just gonna be a bit too much for the piece of paper, but I think it looks really cool and it's very interesting. So I wanted to try to do an area of, or to find out the general formula for the area and see what I get. So I've decided to start on first looking at the area of a triangle in general. First of all, this is an equilateral triangle, which means it has absolutely every single side equal. So the general formula for the area of a triangle like this is, so we're doing a half times, I'm gonna call a side A. So I've got A is the side. I don't even know where to put on my drawing, but we've got A is the side for the big triangle. So is this one over here. This bit is A. That's my A. Okay. Times the height in here. So for the height, I kind of need to be a bit more careful for the height. Okay, so this is A over 2. This is a Pythagoras, because this is 90 degrees over there. So to be fair, I'm going to put it on the side, because it already made my... Okay, so this is A, this is half of A, and I need this one. Okay. So that's 3a squared over 4. So my little bit that I have over here, it will be square root of that. So this is square root of 3 over 2 times the a. And this is square root of 3 over 4a squared. So this is my general area of a triangle. Now, there is something that's happening when we do this. So how am I gonna represent this? I need some sort of notation for my first iteration when I start splitting this in 3. So when I split this in 3, I got each side of the triangle to be something divided by 3, and then I've got this little 3, these little triangles over there that are actually that bit divided by 3, and they're all exactly the same. So let me think. So I'm gonna do after first iteration. Okay, now after my first iteration, my new side, so I'm gonna speak about side, I've got A equals, I've got a new side. Should I call it A? No, I'm gonna call it B. My new side is A over 3. Whatever side I had before divided by 3. I think this makes sense. I hope. Okay. So now the new area is the area of the big. Yes, is the area of the big. So the new area is going to be the area of the big shape, which is the one that I've just got the general form there. Plus, and I've got 1, 2, 3 areas of the little shape. 3 times. But I should follow on with the same formula. It's just my new side is not going to be, it's actually the B, which is the old one, divided by 3. And I squared it. Okay. What do I really want to represent here when I do this? I need to think of is there a way I can simplify this one? You know what, I think I'm gonna leave it as it is at the moment, because I don't really know which bits I want to take. I kind of want to simplify as well, but I feel like I don't want to simplify the 3 and the 9, so I'm gonna leave a bit of space there and just move on to after my second iteration. Which is basically what I have here after I started like putting the other even more little triangles there. And now here is the bit where I have to be very careful. How many do I actually have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I had those 3. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. What is the connection? How many do I have? Oh, I see. I will look. Oh, I'm going to look at sides. This will make a lot of sense. So I'm going to look at sides. So if I look at sides, I've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So, I think I got it. Now my new side. This is actually side C, which is the B. Divide by 3. Oh my, am I just making this? Yes, which is B was A over 3, so this is A over 9. Okay. Excitement. I'm getting there. So my new area is the area from before. I've calculated. Okay, I'm just gonna copy it. So that's what I've got in the previous one, and then hopefully after I do this calculation I will figure out how to take the common factor out. Okay, plus, and now I've split this one into 3s depending on the sides, because I think that made a bit more sense to me. So I've got 4 there. So I've got 3 times 4 times, what am I doing? Area of the very little ones. So that's root 3 over 4 times the A over 9 squared. Okay. The excitement is here. So root 3 over 4 A squared, 3 root 3 over 4 times A squared 9. 3 times 4. Oh, I don't want to do these calculations. There's another 9 that's squared. So I've got the 3 over 4 is obviously everywhere. And I've gone, I think this is what I'm going to take as a common factor for the top one. And I'm going to write with another color. So 3 over 4 A squared bracket 1 plus the 3 over 9. I hope I'm doing this right, because I don't really want to change this one. I have the feeling, because it appears here as well. So I'm gonna do the same. Plus 3 over 9, which should be the same as what I had over there, plus 3 times 4, 9 squared. Okay, what's the connection here? Okay, I think I need one more. I need one more iteration, which is the one I haven't actually done in the drawing, but you know what, that's fine. That's fine. So I need a third iteration. Okay, so this is a random book I have here, so you will see a lot of other stuff randomly here. So what did I do? After third iteration, so let's see. Third. So this is a new side. I'm gonna call it, you know what, you're probably not gonna like it, but I'm gonna take this piece of paper away from here. Okay, so this is side D, which is the C over 3, and my C was A over 9, so this is A over 27. I'm going in powers of 3, so I'm gonna go with 3 cubed. Is that gonna help? Oh my. Do you know what? I should have put this one as A over 3 squared. Does that mean I should have changed the powers there? I don't know. Let's go with the area now. Is the area I just found out here. So that's root 3 over 4 a squared brackets 1 plus 3 over 9 plus 3 times 4 over 9 plus, oh my, how many am I gonna have now here if I make the little, so I'm still going with 3 because I have 3 sides, so 3 times. I'm gonna go with, now I have 1, 2, 3, 4 little sides, and then each of the 4 is gonna have 4 more. Does it make sense what I'm doing? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've got, if I split into 3, into 4, 1, 2, 3, 4, each of the 4 is gonna have, oh, I so wish I searched this a bit before I started doing this. You get like, because I don't have any, I do actually. The shape has a little triangle there. So 1, 2, 3, 4. It's 4 for 4 times 4. Oh, you know what? If I've made a mistake here, can someone just tell me in the comments down below? Because I'm very excited, but at the same time I haven't done proper research on this. So we're getting there. What am I doing? Area. So the side squared. Now I have the filling because this is 3 to the power of 3, but it's squared, so that's 9 to the power of 3. Oh, did I make a mistake there? No, copied it wrong. Which will look really interesting. And then I have another 4. Ooh. So 1 plus 3, 9 plus 3 times 4, 9 squared, plus 3 times 4 times 4, 9 cubed. I'm gonna write it with another color. So this is very interesting at this point, because I have the feeling that every single time I'm gonna have this change here. Like, it's always gonna be the previous one. And the 4 changes. And for my third iteration, I had a 4 squared. For my second iteration, I had a 4. So this was one 4 less, but I've got the power there. You know what? I need to write this down. So if I have K iteration, the term I'm looking at is this one there. So I will have 3 times 4, and I had 2 there. So that's K minus 1 times this. And then I had A over, and now I go a 3 to the power of 3 there, 3 to the power of 3, so that's 3 to the power of K, everything squared, which is actually 3 times 4K minus 1 times square root of 3 over 4 times A squared over 9 to the power of K, which, if I'm looking at how I take my common factor here, it's square root of 3 over 4 A squared, and then I've got 3 times 4K minus 1 times 1. You know what? Let's put it over 9 to the power of K. Oh, I'm out of battery. I need some charging. Give me a couple of seconds. Okay, I hope the angle didn't really change that much. Okay, so I've got a general term for my kth iteration. Now I need an actual area. I don't know why I'm writing with the pencil, but I feel like I might just make a mistake. My problem is I'm continuously adding these ones here, but I'm not going to consider the 1. So I think because 1 doesn't seem to have a lot of connection here. So if I look at this, was my third iteration, so I had squared. My second iteration, I had 1. This was my after my first iteration was this one. So the 1 is just there. Oh, the 1 is there because of the big triangle that we're starting with. Okay, fine. That's my first iteration, so I had 4 to the power of 0. Okay. So my area now is going to be root 3 over 4 A squared 1 plus. And here I'm supposed to have all of these things multiplied together until I multiplied and added together until I get to this one. So that should be 3 over 9 plus 3 times 4 over 9 plus 3 times 4 squared over 9 cubed plus so on. And I've got the general term 3 times 4k minus 1, 9k. Is that the last one? I think so. So if I'm looking at these ones, that's a sum. Oh, this looks it. Now I'm changing. So we've got 1 plus. This is a sum. So I've done my general k iteration. This one I want it to be, so I'm going to go with general. So I'm going to go with the general form for the area. I'm going to say is this one. So I'm not going to use k, I'm going to use n because we feel fancy. So we're going to go k equals to 1 n, and it's 3 times 4k to the minus 1 over 9 to the k. Is that the area? Is this what I'm saying? It is? I should be using like some sort of induction over here to actually prove what I've done. I might just be coming to this one a bit later and do a proof by induction. So I'm going to put it on the side here and be like, I need a proof by induction. So this one needs a proof. I think it's by induction. At least this is how I would do it. Okay, so I will go with, this is the general bit. Now, can I actually find out the actual area? It will probably depend on the side of the triangle I'm starting with. So it's probably not gonna be a number straight away because of the A. So I think that it's really important the size of the first triangle we're starting with, because I think that's a bit more, that's really important, because I haven't changed anything about the size of the triangle I started with. But now that I'm looking at this one, what does this remind me of? Oh, sorry, it took me so long. I'm actually... Is this a geometric series? I think it is. I think this is the partial sum of a geometric series with ratio r equals 4/9. And in that case, I can do a limit because the sum converges as n goes to infinity. I think I can do this. So we can get the area. How am I going to write this? I'm going to go... So I'm used to say that this is a geometric series. Series with r is 4/9 there. And so we've got sum converges as n goes to infinity. What do we have? We've got, I'm gonna write with my pencil because I feel a bit insecure about what I'm saying. So the A doesn't change, but I've got this. So I need this one. So geometric series, come on, remember what we used to do. I hope this is what I'm supposed to write down. I'm so sure there is someone that can correct me in the comments or something. because I feel a bit, like, I will be honest, I feel a bit insecure about all of this that I'm doing exactly here at the end. Up to my general form over here, I think I feel pretty confident about this. But this bit at the bottom, I feel a bit insecure. So correct me in the comments down below if you've got up to this far, because I presume the video is going to be pretty long. If I'm doing this right, I should have done a bit more research before I put this, but I'm just a bit too excited at this point. I think this is what I'm supposed to do. Okay, so I need to simplify my lovely fraction here. So this is 5/9, 3/9. So it's 3/5. This is going to be 5/5, so this is 8/5. How can it be so cool? Can it be just like that? It can't be. Just tell me. This is so cool. It's just 2√3/5. And then A is the side of my triangle, like the original one I started with. And that is it. What? I mean, for some reason, this fascinates me. How can it be just this? This is so cool. Please tell me I've got some bits from here right, because I might have made a mistake, but this is so nice. Wow. Okay, that's me just being overly excited at whatever, this is like 7 o'clock in the evening, trying this bit, and I think this is so cool. I might actually rewrite this one and do a bit of research on the back here just to check that I've been doing the right bits. This is cool. I'm excited for that. If you managed to get up to this point in the video, I don't know, and I haven't made a mistake, just leave me some sort of a comment being like, well done. But yeah, this is cool. Great. So I'm gonna leave my final answer over here as the last bit, and yeah. I hope you managed to get up to here, and I'm very thankful if you managed to get up to here, and I'm very excited if you did get up to here. So yeah, I will be speaking to you soon. I hope you're having a lovely day, and yeah, enjoy. Bye.